All right, section 10.4, probabilities of disjoint and overlapping events. Here's the deal. Probability is easy when it's easy, and then it gets hard when there are more than one things going on at once. And that's what we're going to start getting into today. It's still logic. You can still think about it, but we're going to need some more advanced tools. So, essential question, how do I calculate probabilities when two events are occurring at once, not just one? So, let's look at our first example. Just kidding. Let's look at this meme of Psy. I don't know if I really get it. Anyway, first example. All right, so here's the deal. There's a lot to take in on this slide, so let me kind of take you through it. I have some people. Here are my people, and I have some data about this people. I have what gender they are. I also have whether or not they play soccer. So like I said, we have two things going on at once here. We have the gender of somebody, and we have whether they play soccer. This is two different things. We're going to call event A being a female. So if you are a female, you are part of the probability event A. Event B is playing soccer. So if you play soccer, you're part of this event. So we can look at some people that are part of event A, like here's a female, she's an A. Christine's also an A. Emily and Gabriella, they're also an A. And then we have some soccer players. They'll be in B. So like Alyssa's also in B. Dalton's in B. Emily's also in B. Gabriella's also in B. So we have a couple things different going on here. We have somebody who's in no events. We have some people who are in one event. And we need a way of organizing all of this data. And the best possible way to organize all this data is a Venn diagram. Venn diagrams will be your best friends for this chapter. Hopefully you know how they work. In this circle is going to be all of the people that fit into event A, all of the females. In this circle is going to be all the people who fit into event B, the soccer players. These people are the ones that fit in both, and then this is something you may not have seen before. If you imagine this whole Venn diagram being in a big box, which has the little spike that I love that happens with my pen, outside is going to be the people who are in neither event. In other words, they're not cool enough to fall in either bubble. So let's just take a second to put these people in place. We have Alyssa. She is both a female and a soccer player, so she's going in here. Bob, he is not a female. Also, he's not a soccer player, so he's going to be going in the outside zone. And then I'll keep filling in. Christine, female, but not a soccer player. Dalton, he's a soccer player, but he's not a female. Emily, she's a female and she plays soccer. Fred, he is a male that doesn't play soccer, so he's also in the outside zone. And then Gabriella is one of these girls that fits in the overlapping. So again, girls in the overlap, they play soccer and they're girls. This person is a female but doesn't play soccer. This person is a soccer player but not a female. To figure out the probability here, all we need to do is look at our circles. And I like to kind of disregard everything else, and I'll show you how to do that. So for example, the probability, here's what this means. This is the probability of picking somebody in event A. In other words, the probability of picking a female. So if we look at everybody that's in this circle, how many people do we have? Well, of course, we have 4 people. So it's going to be 4 out of how many total people? 7. For the probability of event B, we're going to look at the B circle. So we have, again, 4 people. And just so you know, I'm including this guy and the people in the overlap. I'm including everybody in that circle. But now we start getting into some tricky categories. For the next one, we're looking at the probability of not being in A. And we call this the complement. The complement meaning we're looking at everything outside of that probability event. We notate it like this. We can say the probability of a complement, and it means everybody that's not in A. Now let's think about this for a second. Let's think about who is not in A. Well, if A is being a female, the people that are not in A would be the males, right? And so we could look on our chart and see like, okay, we have 3 males, but let's notice some things about these numbers. First of all, if I have 4 here and 7 here, what do those add up to? Oh, the 7 total, right? So an interesting thing about complements is that they always add up to the total number. 4 plus 7 equals the total number of 7. A way that we can look at the complements in the graph is we can look at everything that's not inside the A circle. So what I like to do is I like to literally scribble out everybody that's in the A circle and look to see who's left. Well, this guy's not in the A circle. This guy and this guy aren't in the A circle. How many people? It's 3. Nice. So now let's do not B. So again, if event B is the probability that you're playing soccer, event not B is going to be the non-soccer players, right? The non-soccer players. So again, what we can do is we can look at the soccer players. Hey, there are 4 of them. They play soccer, so shouldn't not B be 3 players? Because if 4 people play soccer, isn't it very logical that the other 3 don't play soccer? So these probabilities do add up to the total. Or what I like to do is literally just cover up everybody in B. How many people are left? This guy, this guy, this guy. That's 3 total people who aren't in B. Next, we have some more complicated probabilities, and here's where we're starting to get into the compound events. What does it mean to be in both A and B? Aren't these the people in the overlap? And how many people are in the overlap? Well, I have 3 out of the 7. So A and B means the overlap. But let's think about what A or B means. That means if I pick a person that's female, I have a person that works for the probability. If I pick a person that plays soccer, I have a person that fits for the probability. Or I can pick both, right? Okay, so let's look at who. Alyssa, is she female? Yes. So she's in the probability right away. It just so happens she also plays soccer. Bob, well, he's not a female. He's not a soccer player either, so he's neither, so he doesn't work. So do you see what's happening here? Basically, as long as somebody's in this circle or in this circle, and by extension, the overlap would count, I have my or. The only people that don't count are these guys. They're the only people that aren't female or don't play soccer. So let's count my total people. It looks like I have 5 out of 7. This guy, these 3, and this guy. They are either in the A, these 4 people, or they're in the B, these 4 people. I have 5 total people. And then let's look at neither A nor B. So again, here's where since we have a negative, I like kind of covering up things. So in this case, neither A, so A doesn't work, nor B, B also doesn't work. The only people that do work are these 2 people. 2 out of 7 people. Notice that these 2 events are complements because total, these are the people that live in the bubbles, these are the people that live outside the bubbles, including all of those people. I have the total number. Oh man, I'm already 9 minutes into the video, and you told me I need to make my videos shorter. So look, I have this slide. Let's forget it. I'll just cross it out. I have this slide with some definitions. I'll do that real quick. And I'll have this slide that I'll also cross out. It's so sad that I'm crossing out all these slides. Anyway, let's just do a quick definition. Disjoint mutually exclusives. We'll save it for class, but I want to remind you what a complement is. A complement is best defined as all the other stuff. And what we learned is that you can notate the complement of A with a bar, like a little line over it. And remember that since you have all of the other stuff, if you're adding up A plus the complement, it should be the total stuff. Or if you're adding up their probabilities, probability of A plus probability of the complement, doesn't it make sense that they should add up to 100%? Or like 1, if you're not thinking about it in terms of a percent. So that's the complement. All the other stuff, they will always add up to 100% of the people. All right, thank you very much for watching. Yeah, we'll finish these notes in class because there are a lot of ways you can go with these problems, but this is a good introduction.